Hello and welcome to this how-to guide from Quantique. In today's video we're going to help you understand the local MQTT broker that resides in our QuarkLink security platform. First of all, let's have a look at what is MQTT. So MQTT stands for Message Queuing Telemetry Transport. It's basically a lightweight publish-subscribe machine-to-machine network protocol used for message queuing and message queue services. It's designed for connections with remote locations. Typically these you'll find for the IoT of things, where the connection is in a device that has constraints on its resources and maybe the network bandwidth is limited. Typically it must run over a transport protocol that provides ordered, lossless, bidirectional connections. So this is ideally TCP/IP, but also possibly over QUIC. What is an MQTT broker? So an MQTT broker is a piece of software that runs on a computer or typically in the cloud, certainly in the case of the QuarkLink. And it is available typically as open source, or there are proprietary implementations, which again is what we have for the QuarkLink. In the QuarkLink implementation, it's called a local broker. Now the broker acts as a post office, so MQTT clients or IoT products don't actually use a direct connection address to the intended recipient. So what they do is they use a subject line called the topic. Anyone who subscribes receives a copy of all messages for that topic. So multiple clients can subscribe to a topic from a single broker, so that's one-to-many capability, and a single client can register subscriptions to topics with multiple brokers, so that's many-to-one. Let's now have a look at the QuarkLink Local MQTT broker. For this broker, the access point is via the default port for MQTT using the QuarkLink instance URL. So this is your QuarkLink Ignite URL. Now the default port for MQTT is 1883, but of course at Quantique we want to ensure that all your communications is secure. So the QuarkLink Local MQTT broker is secure using TLS encrypted channels. So when you use a TLS encryption channel, the default port is actually 8883. So here on the diagram you can see that the access port for your local MQTT broker is HTTPS, then the QuarkLink instance name, which is in the URL for your QuarkLink, .quarklink.io, port 8883. Once connected, your device can publish and subscribe to topics via this URL and port. So topics will be handled by the broker as appropriate, supporting one-to-many and many-to-one capabilities as we mentioned earlier. In the case where multiple brokers are required, a separate MQTT broker instance is created for each defined MQTT IoT hub, which you will see in the video moving forward. Each with its own topic space, which is not shared by other local MQTT broker instances. So let's have a look at our QuarkLink Ignite and create our MQTT broker. So I need to create an IoT hub. Let's give it a name and the type, and of course it's going to be MQTT. Save that. Now I need to associate a device ID with the hub and a policy. So I do this by creating a batch. Give it my batch name. The policy is the validity dates for the certificates and of course the type of connection. So let's create a new policy. I'll give it a name. The type of connection, in this case it will be an IoT hub, not a direct database. And the one I just created, MQTT. I'll save that. I'm going to put some firmware in the device. We'll just use some standard V-fused firmware that's good for development and a key I previously created. Okay, my batch is now done. Let's now start a provisioning task to program my device, which I've already connected to my PC through USB. So let's give this task a name. I'm going to use the M5 edu kit here. Let's give it a bootloader, V-fuse of course, so that I can use this for development, and I'm not going to program eFuses. So this is the batch that I previously created that's going to be associated where the device IDs will be programmed. Okay, let's go for programming. I've got a local hotspot on my mobile phone. Let's type that in. This is the network that the IoT device will communicate to the QuarkLink through once it's been programmed. Okay, let's start provisioning. So as I said, the device is plugged into my PC. It's now going to connect. So I need to tell it which port. And now the device is being programmed. It may request to be reset, and then it's going to program the encrypted firmware into the external flash. So this can take a little while. Once complete, a unique ID will be generated, and that will have been put in the batch I previously created. Okay, let's open a terminal and see what the device is doing. I'll connect to it again, now through the terminal. And you can see here it booting, and it's going to now download the firmware that I associated in the batch, and it's actually going to download it to the device. So you can see it doing here at this point. Whilst it's doing that, let's have a look at the MQTT broker and see if we can see any messages being published. We'll wait while the device is programming, and once it restarts, you'll see messages being sent or published to the MQTT broker, which is local to the QuarkLink. So here we are rebooting, and now we should start sending some messages or publishing messages to the local broker. Here you can see it's just sending some count information. And you can see the debug information is linked to the information being received by the broker. Let's see if we can go the other way now, and I want to publish something to the IoT device. So here I need to have the topic information, of course. So I'll paste that into the topic, and I'll just send a message to the IoT device. Let's just send hello world and send. And you can see the message has been received by the IoT device. So my MQTT broker is up and fully functional. Thank you for taking the time to watch our video. Please follow Crypto Quantique on YouTube, LinkedIn, and other social networks that are listed in the description for more helpful guides.